Hello everyone, I am Dr. Sirajul Faizi. I welcome you in my YouTube channel. Today in this video, I am going to talk about analytical evidence of benzene. Analytical evidences of benzene. How you confirm on the basis of analytical data benzene is present or not. So first technique, Irs spectroscopy. When a sample mixed together with KBr and converted into pellets passed through IR beam gets vibrated or rotated and shows peak. That is the functional groups. Purpose to determine the functional groups. Now you have the NMR technique, nuclear magnetic resonance spectroscopy. When sample is kept in magnetic field, hence proton present in the sample acquires resonance and gives peak, number of proton and carbon. Purpose to determine the chemical structure including carbon and hydrogen. Mass spectroscopy, electron bombardment on sample, hence ionization of samples to form molecular ion peak and fragment peak, molecular weight. So purpose to determine molecular weight. So Irs spectroscopy, carbon-carbon single staging 1500 per centimeter, carbon-carbon double stage 1600 per centimeter, CH stage 3000 per centimeter. So Proton Nmr spectroscopy, 6 proton gives one single peak, chemical shift 5 to 7.8 delta value. So carbon 13 Nmr spectroscopy, chemical shift 150 to 160 delta. 6 carbon couples together give single peak. So mass spectroscopy, it gives the molecular ion peak at 78. These information keep in your mind. So Irs spectroscopy, you know the principle of Irs spectroscopy, and Irs spectrum is essentially a graph plotted with the infrared light absorbed on the y-axis against the frequency or wavelength on the x-axis. Irs spectroscopy detects frequencies of infrared light that are absorbed by a molecule. You know, molecules tend to absorb this specific frequency of light since they correspond to the frequency of the vibration of bonds in the molecules. What is the procedure? When sample mixed together with KBr and convert into pellets, pellet passed to IR beam get vibrated or rotated and shows peak. So this is the spectra of benzene of Irs spectrum. You can see transmittance versus wavelength. Wave number is the centimeter inverse. So x-axis you have the centimeter inverse. Just remember wave number, and y-axis is your transmittance. So types of stage you are looking: carbon-carbon double bond stretching, carbon-carbon single bond stretching, carbon-hydrogen stretching, because such type of bond presents in benzene ring. Now you can see this peak in your spectra. In 3000 regions, some very nice peak is there. At 1500, very nice peak is there. At 1600, also very nice peak is there. So, NMR spectroscopy. What is the purpose? Nuclear magnetic resonance, you know, spectroscopy is an analytical chemistry technique used in quality control and research for determining the content and purity of sample as well as its molecular structure. It will detect number of protons and number of carbons. Number of proton determined by Proton Nmr and number of hydrogens by carbon 13 Nmr. So number of proton and number of hydrogen, number of carbon, types of carbon, and carbon 13 Nmr. So benzene contains 6 hydrogen, 6 carbon atoms. So Proton Nmr and carbon 13 Nmr gives single peak with chemical shift 7.26 delta value. So you can see in Proton Nmr spectra of benzene 7.26 ppm and benzene carbon 13 Nmr 128 ppm, single peak, because all proton are the same. So mass spectroscopy, what is the principle? Electron bombardment on sample, hence ionization of sample to form molecular ion peak and fragment peak. You can see the molecular weight. So purpose to determine the molecular weights. What is the purpose for mass spectro Scopy, molecular weight determination. So molecular ion peak, you know, C6H6 78 m by Z, fragment ion peak C4H4 51 m by Z, and fragment ion peak carbon 3 hydrogen 3 39 m by Z. So my friends, I hope this video will be helpful to you. If you like this video, then subscribe my channel, and thanks for watching.